Well, first off, I want to welcome everybody to another coffee session. We have a really special guest today, and we also have Demetrius alongside with us. We have Damian Brady,
Not
who's a
so
senior.
special guest.
He's a senior cloud advocate at Microsoft. He recently did a meetup with Demetrius, and they were talking about some really fun stuff around DevOps and MLOps. You may have seen him in the chat having some fun conversations around just DevOps and the relationship to MLOps, the distinctions between them. And we have some fun stuff today. Demetrios, why don't you and tell us a little bit about what this background music is? What's going on in the background?
Yeah, just a quick aside that we've got Dan Jeffries' AI-made music playing in the background, and it is this ambient music that he created with his model. And what it did is it took a list, his playlist that he's had since the 90s, it analyzed all of that, created from audio to MIDI, and then it recreated different tracks that are similar in similar styles. And then he got to put it through like Pro Tools, or I think he was using Logic, and he would say what instrument he wanted it to play. So he's got a whole playlist. We'll link it in the show notes because I just thought it was fascinating.
That's really so cool. It's a vibe. So this is the coffee session vibe for the day. Thank you for that.
Hopefully nobody falls asleep on us. It is the ambient music. It's more relaxed, like background music, rather than the hardcore experimental jazz we had going last time.
Yeah, this is more for focusing. So we're gonna have a focused conversation, maybe.
Well, focused chat.
Yeah, we're hoping to have just a fun conversation today. Damian has a lot of experience with DevOps, and we just love to just talk a little bit further about that. Hopefully add on and continue the conversation from the meetup.
Yeah, I think the main first question that everyone has, right, is what is DevOps and what is MLOps? How do they differ? So
yeah,
you want to go ahead and try and take a stab at it, Damian?
Sure. Yeah, so first, thanks for inviting me along. It's good to sit and have a chat about this stuff. So my background's all DevOps, really. I've kind of been doing that for the last, in some form or another before it was kind of DevOps.
What was it before then? What was it like typically called?
I mean, people have been doing those practices for a while. Like, I think it wasn't really given a name until I think it was Patrick Dubois kind of coined it. And I don't remember when that was actually, but I know it was in Bruges, which is not Bruges, Ghent, right near Bruges.
Oh, yeah. This is like around the time when Gantt charts were like coming out, things like that. Is that what you're talking about? The Gantt charts?
No, Ghent in Belgium. So
right near Demetrios.
Yeah, GHENT. Anyway, this is kind of an aside. But yeah, Agile before that, just the whole process kind of stuff is really where it was at. And then I've been a dev for like 20 years.
Nice.
A paid dev for 20 years-ish. Unpaid for longer. I was one of the people who did kind of the, I don't know, I programmed when I was 10 kind of thing.
Nice.
Yeah, it was pretty cool.
Did your parents get you into programming, or you just kind of got into it on your own?
Yeah, a little bit. I saw some thread on Twitter the other day about people saying, does anybody actually remember, or are they old enough to like have typed in all the stuff at the back of a magazine to create an application stuff? And yeah, I totally did that.
Oh, wow.
Wow.
Yeah, you just typed in a whole lot of stuff, and then hopefully it worked. And if not, you didn't get great error messages, but yeah.
That's always bad.
Yeah, that's right. But it's obviously like it's evolved since then. But I've been I moved a little bit from the cutting code stuff as a priority to the process stuff, I guess.
Nice.
How to write better code, how to work collaboratively with other people in the team, and then kind of kept shifting towards the DevOps perspective, I guess, which is all about kind of how to get an idea from just an idea all the way through into production and make sure it's valuable and do that as efficiently and effectively as possible. I think coming back to your question, and I'm speaking about a focused conversation, I don't think I'm doing too well.
No, you're doing great. I love it.
It's the ambient music.
Yeah, it's the ambient music. I'm just drifting off. Yeah, coming back to that original question, what's the difference between DevOps and MLOps? I think from that point of view, it's the same thing. And I know there was a discussion about this the other day on the Slack as well about is MLOps just DevOps? And I think from that really high level perspective, it's about getting, some kind of solution from your head into the hands of people and make sure it's valuable and do that really effectively. Like, of course, it's the same thing. Like, it doesn't matter if it's a bit of code or it's a database update or if it's a predictive model or something. Where it differs a lot is in some aspects of how you actually get that, like the processes involved in producing that model and then deploying that model and stuff like that. So conceptually, I don't think it's that different, but in practice, it's definitely, fairly different, I think.
I agree. I think in my mind, these are like these sorts of words, DevOps, MLOps, they're like mental models. They're useful, right? But they're not perfect, and they're helpful to kind of organize our thoughts around different sorts of things. Like for me, I look at it exactly the same way. It is DevOps, but the differences for me are like some of the nuances and what's going on with the software itself, with the application itself, right? The data component, the randomness. Another thing for me is that there's not always a right answer. So you can't really, you could from a software perspective have a perfectly functioning app, right? It works, it's handling the load of all the traffic, but maybe it's giving crap answers. And it's very hard to kind of look at some of these things if you're only looking at it from maybe traditional software or from like that sort of perspective. But like you said, conceptually or philosophically, they're pretty much the same thing at a high level, collaboration, how to take some idea and bring it to life so it actually brings value to the end users. That to me is all the same thing. And so I'm never so picky about like, it's not DevOps. It is. It's just, I guess, it's helpful to to differentiate them. I guess in particular for, maybe your management to understand some of the differences, the added complexity that's maybe there. And I guess if you underestimate that, it could be difficult.
Yeah, for sure. And I think some of the danger with these buzzwords is that people will say, it's DevOps, therefore we can use all the existing DevOps tooling that we've always used and the processes, and hey, let's just apply, Git flow to our machine learning project and CI. So every time anybody makes any changes to the code, let's just do a training run. Like in some cases, I hope you have really deep pockets if you're going to do that. And then just roll it out to production and stuff like that. You've got to be aware of like where the limitations are and where the differences are. Because the cadence is definitely different between traditional software and a machine learning project. There's a lot more experimentation, at least, especially initially. Whereas, I like to tell people, like in the last 10 years, maybe, I used to do consulting kind of before this job and before the previous one. And day one, we'd go in at a new project and they would say, all right, we're going to create this brand new application, but day one, we would create Hello World and a whole delivery pipeline and push that into production. And that was day one. But from that point on, we didn't really need to worry about that pipeline at all. It wasn't a case of like writing everything over 6 months and then picking it up and saying, right, how do we deploy this thing? We could kind of start with that process and go all the way through to the end, I think. And I think I've kind of lost my train of thought there.
No, you're good. I was gonna follow on that. I think this is sort of an aside, but that's typically what I would recommend, is that it's good to build like just like an end-to-end pipeline of what this could look like with the dummy model. Just even something as simple as just like multiply two numbers. But to show that works makes it a lot easier to research, to iterate, to experiment. And that's to me like what I love about all this stuff, is that it's like for people think, you're always thinking about these good practices. In my mind, I'm just covering my ass. I'm trying to like make sure that I'm in a safe space to add new things and not break things later. to make sure that I have like some expectations of how this thing is going to work. And if I don't like start thinking about that as I'm, building the model, as I'm developing the algorithm, as I'm, engineering things, it's so easy to like over engineer in one area and then forget about some of these more important things that, a DevOps engineer has in mind, like from the get go. And so I think that's one of the beautiful things about this, is that it just helps you kind of guide that ideation, that like hypothesis generation stage, and bring it into something that actually can create value.
Yep. And I mean, you can get great results in your like internal validation and your testing and stuff like that. But then when it actually hits real people or a real environment, then it might not be doing what you think it's doing. And I think that goes for traditional software as well as ML, but I think it's probably a bit more visible in the ML world, predictive modeling. So, hey, this worked great in our test data, but when we put it in a real application, it's not working. Yeah. And unless you're actually putting it in a real application, you're actually deploying the thing out, then you just don't know, you're guessing.
Yeah, it's a bit of a crapshoot.
Can I have one question around this, Damien? Because I know we were just talking about this in the chat, and I actually had another conversation with a coworker about this. Shout out to my coworker Lucas. But one of the things we were talking about is you mentioned that production can be a test environment, and I actually agree with that. Especially after hearing some of the use cases where my coworker found it very useful. I would love to talk a little bit about that. Like you mentioned, like you won't really know the full behavior of a system until it's actually being used by real people in real time and these things like that. And can we talk a little bit about why that's particularly difficult with machine learning applications versus, let's say, I don't know, some sort of like simple app or something like that? Because again, those are actually not that easy to deal with either. Like, let me make that clear. But there are some differences there.
Yeah, definitely. I'd almost go further and say production is a test environment. It's always a test environment. It's just you're trying to, like with your other environments, you're trying to test as much as you can without impacting production. But it's never like the rubber never hits the road until you actually are putting it in front of real users. I saw a really good suggestion. Yeah,
sorry, go ahead. Actually, no, you first, and then I'll add.
I was going to say, I saw a really good suggestion in there, which surprisingly I hadn't come across before. It seems really obvious in hindsight, but it's the shadow deployment. And I think it's mainly because that makes a lot more sense in an ML world where the idea for people not familiar, I think, and I'm paraphrasing, but the idea is that you deploy a new version of the model, and all of your production traffic, or maybe some of your production traffic, will go through that model. Like you'll pass that through your new model as well as the one that's running in production. So 100% of your traffic goes through your existing production model, and then some of it goes through the new one just to verify that it works. So it doesn't actually affect what people see in production, but you're still running production data through it. Does that line up with what you?
Yeah, absolutely. One I guess criticism of this view that some people had was that the results of the model just kind of get thrown away. But I guess if you're okay with that, then that's not really that big of a deal. Like if it's fairly inexpensive to generate predictions, if it's not, like, again, if for us, like in my company, we use Redis, so we temporarily cache all those predictions. And the reason why is that it's relatively inexpensive to just regenerate those predictions. It doesn't take too long. They don't need to live for that long. And so for these reasons, for us, something like this actually would be okay. It wouldn't be that difficult. But I could imagine, like, if you have if you're really concerned about not so much, the performance of your model in production and like testing that to make sure it's good, but rather you care more about some of those downstream effects and the metrics. Like I think Laszlo, he was talking about, what about the metrics? And I'm like, look, those are all valid questions. But if you're just thinking about, does my endpoint have enough memory to stand up my model? If you're looking at some basic things like that, then this seems like it's a reasonable way to do that. And it's also safe, like you mentioned.
Yeah, for sure. I think those ideas behind, like the idea of having to test what you produce against the real world before you really know whether it's going to work as expected or if it's better than what the previous version was. I think that's a little bit more visible or more important maybe in machine learning or in predictive modeling rather than in traditional software. If you think about like you write a new feature for a basic forms over data kind of app, a really basic traditional piece of software, you can test that pretty well. You can even give it to a QA department. Like you can do all that kind of stuff, push it out to production. And if it doesn't work as expected, that's fine. You iterate on it and it's not too bad. But partly, and in a lot of organizations, they'll just say, well, we met all of these requirements. It does the thing that it's supposed to do. It's in production. People are using it. We'll deal with bugs as they come up. And maybe it's not ideal, but it does the job. I don't think you can always say that with a predictive model. Like the outcome you're looking for is a better result from what you've generated. Like you want something that's actually legitimately valuable to the end user, not it checks a box, And so I think there's a lot more focus, or there should be a lot more focus on evaluating that value from is this meeting the goal that we actually wanted it to meet? Like, is it providing the value we wanted it to provide? I'm not saying that doesn't belong in DevOps, and I think it definitely should, but I think that's a bit more maturity than a lot of traditional software development shops have. A lot of the time it's just, have we written this feature correctly? Has it gone into production? Are people using it? Is it throwing errors? And then great. Rather than is it delivering value and being effective?
And that can be hard to measure, right? That's like, sorry, Demetrius, you wanted to say something?
No, yeah, go ahead on that.
I was just going to say that that in and of itself is actually non-trivial. Like I'm thinking of, what's the relationship between, like, let's say a model metric, like your accuracy or the, recall, and actual like click-through rates or some of these more high-level business metrics. And, like in a live model that's being used in production, finding the relationship between those two things, maybe, for example, in my use case, we don't have the answers available right away. For us, we have to wait till we test them in an assay in a lab, and that's a lot of money and it takes a lot of time. So I won't really know the real value of my predictions until much later. And so when you have that slow feedback loop, it makes it a little bit difficult to know, like, when it's actually being being used live, whether or not it's actually providing the value that I need. There's some ways, you can, sanity check it and do some things like that. But in general, like you mentioned, it's, I don't know if I personally haven't seen those same sorts of, like, I want to think about them as like scientific concerns, like the scientific quality of the output, and not to say that you can't have it in a traditional software application. You can definitely have that, because I've seen some pretty complicated apps out there. But it's just this, that element of not always being able to know whether it's good or bad. A good model, a bad model, these are relative questions, and they depend on how you frame it. Like I've been in a situation where I can frame it in such a way that my model is awesome because I framed it that way. But then if I frame it in a different way, maybe taking into consideration one of my other stakeholders, evaluating some metric or something like that, it may do terrible. And so I think those like added elements of not always being able to know, whether it's good or bad makes it particularly difficult.
Yeah, definitely. I think so.
Yeah. And on that, like, just a little bit of a tangent on this whole idea of testing and how testing is a lot harder. Maybe we can go into that a bit more. Like you're talking, David, you're saying, framing it is one thing. Also, I've heard problems with replica data. You're not actually using the real data, and so then you don't get the full story. Are there other things that you've seen that make testing a little bit more difficult?
Yeah. So in the kind of traditional software, the stuff that I'm used to, there's this trend towards automating that testing as much as possible. So taking it out of the hands of people, because that slows down your cycle, basically. I know that within Microsoft, so there's this presentation that a bunch of us do, but it's about kind of the agile transformation and digital transformation of one of the main products that we produce, which is Azure DevOps, which is that whole DevOps tool set. They went through this I think it was about over 10 years they've been doing it now, improvement of their process and stuff like that. One of the big things they did is they started moving all of the testing from manual exploratory and integration kind of tests to unit tests and contract driven ones. So is this small piece doing exactly what it should be doing? And so they got to a point where every single pull request would run 82,000 unit tests. So every commit across several hundred developers every day would run 80 something unit tests, but it'd run fast. Thankfully, like Microsoft's got access to a fair bit of hardware, so we could scale that up pretty easily. But the idea was almost nothing was like hands-on, can we try this and click around and make sure it works. Most of it was driven towards that unit testing stuff, which really improves your cycle time. Like it meant they could do a major release across this product every 3 weeks, as opposed to, I think it was 18 months when they started the whole journey.
Wow.
And so every 3 weeks, a major release, but they could do it multiple times a day if they wanted to. Like I'd seen a bug fix go out basically on stage with one of the presenters at Microsoft before. So they could do that, but there's downsides to that as well, especially if is this successful is a little less easy to work out, like you were suggesting. If it's not as clear whether the thing you've done has proven to be successful, then that massively reduces your ability to do that, to kind of shorten this testing time. I think that's one of the huge challenges. Like you can look at your metrics and say, well, this, the accuracy's gone up, and I don't know. I'm obviously not. I'm by background not an ML guy, but our false positives have gone up, and our sum metric has gone up, and all that kind of stuff, and that means that we've improved it, or it doesn't. You can do it at that kind of shallow level, but all of the other stuff as well, it's a little difficult to tell for sure sometimes whether you've tested everything that needs to be tested, I guess.
And something that I also am thinking about is, like you mentioned, like traditional software, right? You're deploying a lot of times in a day, right? Like it's like everything's through a CI/CD sort of framework, and that's good, right? Removing a lot of hands-on things. But with machine learning, I find that actually sometimes a manual check is actually very important, and sometimes it's not worth the overhead of trying to automate everything. Automation does bring a lot of value, makes things more predictable, which is huge just for a business context, right? But sometimes it just needs to be done manually, right? You need some sort of person that understands this problem. And I think one good goal, though, is to try to at least document and distribute these sorts of things. So you have that reproducibility aspect, which is great. You have knowledge sharing. But if it's just too complicated to automate, for some of the reasons, like actually evaluating the model is not as easy as looking at a metric, but you need to do something a little bit deeper. I think for these sorts of use cases, it makes sense to have a more manual process, and that's okay. Automating everything doesn't always make everything easier. Like you mentioned, it actually can cost a significant amount of overhead. It's expensive, if you don't have a lot of computational resources, like you mentioned, that's a lot of tests that you're running. And over time, it's like, wait, you have so much coverage on this code base. Awesome, but the model's shit. And that can definitely happen, and I think one question I had is, since you're coming from a traditional sort of software engineering background, what are some of these sorts of like scenarios that you've seen in, I guess, the machine learning ops space that you didn't see back in the day when you were working in a traditional DevOps space? Like, what are some of like these like war stories? Like I can't really think of anything off the top of my head, but I'm sure you've seen some like big differences in deployments and like maybe, things going wrong in a deployment scenario.
Yeah, I mean, at some levels, you look at the maturity of that whole process in a lot of ML orgs, and it's almost like it's 20 years ago in traditional software. And it's not supposed to be like a dig at data scientists, machine learning experts and stuff. It's more, there's so much experimentation and so much stuff that requires, almost like experimenting on stuff, and maybe I hit a dead end, after spending a couple of weeks on it. That's the kind of stuff where it wouldn't really happen with traditional software. I mean, if somebody goes and writes some code and it's wrong and is wrong for 2 weeks, then I don't know. That's yeah.
They're getting fired.
Not as accepted. Yeah. Well, I didn't want to say that, but yeah, pretty much. Yeah, but I mean, that's all learning and that's all valuable stuff with an ML project potentially. Like you might try to solve a problem using a whole huge technique. Like you might look at a problem, look at the data you're getting and try it in a particular way and then find, well, that's not actually getting us where we need. And so we're going to go somewhere else or try something else. But what I think what that means is all of the kind of process behind that delivery cycle that seems less important because the cadence is so slow and there's so much experimentation that there's not really a need to have a pipeline to push out to production every change, right? So that kind of gets put to the side, and it's completely understandable. Like, why would you put a pipeline in place if you have to do weeks of work before anything's even worth putting out in production, you know? But as a result, I've kind of seen, right, we've got this model. How do we create it? I don't know. It was like the 4th one I tried last Tuesday, and it was using data from somewhere. I don't know where it was, but this is the file. Let's put this somewhere.
This is the golden file that we need to.
Yeah. Can you reproduce it? No.
Good file. Label it correctly.
Yeah, exactly.
Man, so I got a quick question on this whole, because I know you've talked a bit about the organizational side of DevOps too, and I'm wondering about this idea of, okay, since you kind of juxtapose these two worlds of DevOps in software development can iterate really quickly and you can get stuff out the door, but in the data science world and the ML world, it takes a bit longer. And I'm just wondering about like the organizational side of DevOps, and is there some kind of like these where there's tension being built because it takes longer with the data science and ML world?
Yeah, definitely. And if you have one thing as well, like one of the big changes I think I've found is that ML and AI stuff in day-to-day applications, like in the software that we write, is just much, much more accessible than it used to be. So having something that does like image recognition or like handwriting recognition or something like that in an app is like, it's accessible now. Like you would have had to have a team of data scientists to do that before, and now you don't. Like you can call an API. But the work to produce those models still, in a lot of cases, requires the specialist in those fields who work at a different cadence. So the idea of bringing in like your developers and your data scientists and trying to get them on a 2-week sprint, always releasing something, that clash, exactly like you were saying, that's where that clash occurs. Some ways that I've seen that kind of be overcome is by treating the data science part as almost another third-party library or third-party service that's used by the application. And so they would then have their own cadence that works for them, and they would version that release, I guess, of the ML part kind of separately as a service. So when it comes to actually operationalizing it, it might be, hey, we've got a V2 of this model. You can continue to use V1, but V2 takes these extra inputs because we found, we need these extra features to make it more accurate. When you change your code over to line those up, then you can switch to this model. But it's just like a library or a microservice or something that gets consumed rather than it being part of that application and the data scientist being part of that development team. There are pros and cons to that, obviously. I mean, that means it's basically a separate product, which is good and bad. It means that people are working at not necessarily exactly the same targets, I suppose. But I think that can counter the cadence problem. The other thing that could be done is just the delivery itself doesn't change much. So the ML side, or like the machine learning or data science side, has its pipelines and its things like that, but the bit that actually gets released alongside the rest of the application, that may only change every 10 sprints potentially. And so they still have their pipelines, they still have that process, but a lot of it's still experimentation, and then it just gets promoted at that kind of last point to say, okay, now we can embed this in the rest of the application. The work that's being done, they can still be part of the team and say, hey, so we're trying this other technique to do it, and we think we've got something going here. This is what we're going to do in our next sprint. Here are the experiments we're going to try. This is what we found last time, but there's not really a necessity to say, hey, we've delivered a new version now. Yeah.
It's a great,
wise way of looking at it. Right? Like it's much less pressure on it, and you don't have software developers that are at the throats of data scientists, because like we said earlier, they potentially will lose their job if they're not pushing something out in production every couple days or weeks. So
do you think we're very much getting into the culture side of DevOps as well? Like the acknowledgement of other people's roles and what other people are doing is a big part of DevOps as well. So this idea of the developers yelling at the operations team because they're not letting me change anything and vice versa, or you want to try and, I'm trying to think of the word, but be cognizant of what other people's position is. And so that's important in this respect as well.
I think that one question I have around that is, how much do you think, let's say a software engineer working in a machine learning system, right? Let's say focusing on the DevOps side of it, how much machine learning should they know? Do you think it helps for them to spend time, really learning some of the intricacies of the system outside of just because they're interested? Do you think it would actually provide value in maybe their understanding of the pace at which a data scientist works and why it takes longer than, I don't know, maybe writing some tests or writing coverage for an application? So Michael.
From my personal experience, I think there's a threshold of, like, you need to understand at least these things to be able to really understand what the data scientists are doing. And that took me a while, actually. Like, I remember, like, my initial thought was, when I first came into DevOps and machine learning, and I didn't know much about machine learning, and I was like, okay, well, surely you can just apply the same kind of stuff to ML. And then I learned a bit more, and I was like, well, surely you can't do any of this stuff. Like, it's not going to fit at all. And then learned a bit more, and I'm like, oh, okay, so these bits have parallels and these bits are different and so on. I think until you get to that kind of, oh, I understand what they're doing, like, I'm not the kind of person who's going to be able to sit down and write from scratch a training pipeline to produce something beyond, a pretty basic regression. I'll be copying and pasting a lot of stuff from Stack Overflow.
I think, though, it goes both ways, though. I think a data scientist can really benefit from understanding the domain of software engineering and really, how that should be brought into their own work. I think it actually make their work better, going back to what we talked about in the beginning of, covering your ass. I do think that, like thinking about test-driven development and, using continuous integration and continuous delivery, like these sorts of things actually make you a better data scientist. They help you build better solutions, more robust solutions. And that is a part of what a data scientist does, in my mind. You do build some things. Maybe that's not your primary focus on shipping it out, but it can benefit. And I know I've because I don't come from a traditional computer science background, I've really been glad to have worked with some people who have been in DevOps for a while and learned from them the things that actually help them deal with all these other, applications. But I think it goes both ways. I just want to make it, a software engineer, if you're working on a machine learning system, you should know a little bit about the system to know why it's so difficult in the first place. Maybe that's just like a good place to start. But a data scientist should know, why does it matter to do it in this way? Why should I not write my code? Or why is a notebook maybe not the best environment to productionize something? These sorts of things that are helpful.
Yeah, exactly. One thing I would say is I get asked, does a data scientist need to learn Git? And I was originally like, oh no, probably not. No, I have now turned that corner. You have to.
Yes,
Yeah.
yes, yeah.
You
How are you
have
going to
to know
share your
Git. I'm
stuff,
sorry.
man?
Yeah.
Yeah.
Yeah. I was like, oh, maybe there's ways around it. No, there's not. Just learn Git. It's not that bad.
And that goes with like, sorry, I was just going to say, it goes in line with like this cultural aspect of DevOps, collaboration. That's a big part of it, right? Like, how do you
Yeah,
share
exactly.
your ideas, your work? Well, you know, Git is like, it's been around for a while now, but it's like the bread and butter of like most of the stuff that we do, right? Like you have to share your work in some way.
Yeah.
Well,
And even the really specific like MLOps stuff or ML stuff, like versioning data is a super difficult problem. But a lot of the tools that are in there now that try to address that problem, they do it on the background of Git. So like Pachyderm and DVC and stuff like that, they use Git concepts because that's the way that the versioning seems to work with software development. So even if you're not doing Git, like knowing that stuff, like those are the concepts that make sense for distributed collaboration, basically.
That was exactly what I was going to ask is like,
Yeah.
you know, how do you feel Git holds up in this world of ML? And I guess you kind of answered it with, well, you know, you have new tools that are coming out, but they're still based on Git. So it doesn't matter which way you look at it, you're going to have to learn Git at some point.
Yeah, I think so. And I think especially now, like I come from a Microsoft background and a Microsoft developer background, which for source control, that meant Visual Source Safe. And sorry if that is going to bring back flashbacks for some people. And then Team Foundation Server. I even co-authored a book on that. So Team Foundation version control started as like I'm checking this file out. I'm the only one who's allowed to edit it. And then when I'm finished, I'll put it back in and somebody else can take it. Git was kind of a very different way of thinking, where it was a case of we can all edit stuff and it has this base, and then we do a merge at the end, and it's sensible in the way that it handles those merges and you get complete control and stuff. But it was very distributed. And especially now when everybody's like, people aren't sitting at the next desk from somebody else they're working with, we're all over the place. Having a distributed version control system that works and is largely accepted, I think is super important now.
So one thing that I've heard about, and this is a bit of a tangent on our DevOps conversation, but since you're here, you're working at Microsoft. I know Databricks is owned by Microsoft, right? It's a company of Microsoft.
I know that there's now you're hitting the areas that I don't quite know.
Don't worry about it. We'll ask another question then.
I thought Databricks was its own separate company, but we have a hosted Databricks offering, I think. Don't quote me on that, but I'm fairly sure that is. Yeah.
We'll cut it out. We'll cut that whole part out in post. Don't worry about it. It doesn't matter.
Yeah. No,
I was going to just say one more thing around the usefulness of like Git and some of these practices for a data scientist or a machine learning engineer. One thing that my job, one of my coworkers, shout out to Isaac again, so all these shout outs, but he recently did a presentation on merge request etiquette. And I just found that so helpful, like, you know, because what he helped me realize is that all of that process is like talking, you know, you're sharing what you're doing. Every little thing counts, you know, like it's and it lives beyond once it's being merged. That work, that conversation still exists, and it's huge to, you know, how efficient you can be, right? Like, for example, someone pushes a merge request but doesn't like write like one line telling you what it is, and maybe there's like 38 file changes or something like that, and you're just like trying to figure out what is this trying to do. But maybe if you have this idea in your mind of I'm talking to someone else, so I'll write a little description, I'm walking through what's important, what's maybe just formatting changes or things like that, and like helping them see the value of that conversation of like, you know, your work. And I think that right there that's just not just for developers. That's just for a lot of people who are working in an interdisciplinary or some sort of collaborative environment. Like for me, before there was Git, there was the first version control, and maybe this is not exactly version control, it's like Word docs, or like Google Docs, where you could like collaborate, like work asynchronously. I'm like, this is great. And this actually is really helpful for a lot of organizations. When I was a teacher, that actually helped a lot of things out. So it's not just for code, actually. It's just for any sort of creative work that this actually can be really valuable, you know? And I think that's also another benefit of learning some of these things.
Yeah, exactly right.
So Damien, you had slides prepared. You want to try and jump into them real fast?
We can if you like. We've kind of drifted a little bit away from the thing, but we can. Like
why not?
It's really just about kind of my idea of what this whole pipeline looks like, and especially the tooling. Like we were talking before about the difference between ML and MLOps and DevOps, and I kind of touched on if you don't really know as a DevOps practitioner how ML works and how it differs, then you might be tempted to say, let's just use our DevOps tools to run our, machine learning training runs and stuff like that. Have a CI process so every single change results in a brand new pipeline run and stuff like that. But I think there are better tools for the individual jobs, and it's not to say that some of them can't be done with the DevOps tooling, but it's not really the right tool for the job, I don't think.
Yeah.
So
some people have even made tools specifically around that. L. O'Brien, we had on an episode a while who worked on CML, right? There's like, again, it's not exactly the same thing. So now some other products are coming around to sort of meet that niche.
Yeah, exactly right. And there's some big differences. I know Ryan Dawson was on the show a little while ago, and he has a really good blog post on why DevOps is different than MLOps. And I haven't chatted to him about it yet, not really, but I think I agree with like 99% of what he's got. I have some areas where I differ in terms of like after production, but I think that's just they're super minor things, but he really nicely explains kind of the difference between what you're looking at and what you're not. But some of the ideas as well, it's kind of, I've done these kind of presentations where I've got a whole pipeline just to demonstrate what the different tooling could be like, or what it should be, I think. So you can kind of think about your pipeline as this very vague kind of data prep, feature selection, data gathering, all that kind of stuff. And then the code and the algorithms and the training runs. So actually taking that data and running it through your process to end up with this model at the end. And then this validation step to say, how does this model perform? How does it go against our test data? You can do some pretty basic stuff with, making sure that it actually, it doesn't lock up your machine, and it actually returns results in a reasonable length of time, and the accuracy is up there and so on. But you get this kind of pipeline, I guess, that's like the ML pipeline, or the ML side of it, which is the data and code coming together to create a model, and then working out whether that model works or not. And this stuff, I think, happens whether you're doing MLOps or not. It just might happen on somebody's machine rather than, in another tool. But if you're going to do that in a repeatable kind of collaborative way, then I think all of that really needs to live on, on shared tooling and shared servers. So your data can be versioned using some of those tools, or at least an acknowledgement of here's where the data came from. You can get into some stuff about explainability with the final model, but having a look at what features were used and what version, and making sure that you're running queries over the stuff to make sure that there's no subconscious bias that comes into the training and all that kind of stuff. And then the training run itself, though, can be these really long running tasks. So in traditional software development, your build, which is kind of, I guess, I like to think of it as the equivalent of the parallel, I guess, of your training run. The build might take a few minutes or maybe an hour if it's a very slow one, but a training run over petabytes of data, it might take, I don't know, you might be looking at a week, you might be looking at tens of thousands of dollars of compute time kind of thing. So
Yeah, it could easily run for days. I have so the models that we use, they train for days. So yeah, that's not uncommon.
And so that whole like CI stuff, you can't do that every single time somebody makes a change, right? And there's other techniques around that, but even from a tooling perspective, the DevOps tools are not built to run a multi-day like training run or multi-day build. Most of the hosted stuff, so especially I know the Microsoft stuff, so Azure Pipelines is one of them, and then GitHub Actions is the other one that's kind of ours as well. They'll kind of stop after a particular length of time. They're meant to be kind of attended builds or attended workflows. So having tooling that is much more around unattended runs where you kick it off and then come back when it's complete and evaluate the model. And you might want to do some like early termination if it obviously looks like it's not going the way it's supposed to go and things like that. But so this part is really the ML stuff, and I think you'd need to use you need to use specialist tooling for this kind of stuff. But then once you have this model at the other end, which is essentially a deployment candidate or a release candidate, then you can kind of drop back almost to your traditional DevOps tools. So because they're quite good at all of the stuff to do with rolling out changes gradually and things like that. So you might take that model and do a pre-production test, QA, release, whatever it is, an A/B test or a canary deployment to deploy to just some people. You gather some metrics around whether that's okay, whether it's performing all right in a real production system, and then you promote it to production, however you want to do that. And there can be a lot more in this. It can be A/B testing and all that kind of stuff.
Yeah, or that shadow release that we were talking about earlier.
The shadow, yeah, exactly right. And these are all kind of, except for the shadow one, these are all kind of techniques that happen in DevOps all the time, and the tooling is built to manage that stuff. Monitoring tools and all that kind of stuff are built to work out whether what you've released is doing its job and doesn't have any errors and all that kind of stuff. So dropping back to the ML tooling then makes sense as well. One other difference though is this kind of retraining necessity, and I've forgotten to change a thing. I've got Azure DevOps release pipeline there, but it could be any kind of DevOps tool release pipeline. But that whole retraining, which kind of is really much more important in an ML system, once you push out traditional software, forms over data, it's not really generally going to become stale. But if you're using a predictive model or let's say like a recommendations engine, and you add new products, then obviously you need to retrain. So there's a few different ways you can do it. You can do it like periodically, just run that training run again, and then obviously run the deployment again and make sure it actually goes through that pipeline. So if something does go wrong, you're not pushing the wrong stuff out to prod. And it doesn't have to be a full training run. That might just be part of that pipeline. You might not be able to
have the data. Maybe you just need to retrain.
Yeah, or just, exactly. Just read, or even just do the last step, use transfer learning and pull in the new data and stuff like that. So it doesn't have to be a full run, but the idea would be, periodically do that, or when it hits some kind of drift threshold or some kind of, hey, our recommendations, the click-throughs have gone down. And so once they go down by 5%, then let's do a retrain because something's wrong. There's another technique as well, which is data drift or drift basically. And this is one of the things that's in the Azure machine learning tooling, which is this kind of end-to-end MLOps kind of thing. So you basically start with your training data set. So you have this known data set and you run through your training and you produce a model and ultimately release that out to production, say. But then when it's in production, you can gather the data that's actually being used when it's being interacted with and have that in an inference data set. And then periodically you statistically compare the inference data set with the training data set.
Huge.
And then based on some kind of threshold there to say, look, this is statistically significant according to whatever, automatically kick off a new training run and run through all that again. And same deal. You can just do part of that training run or just do the end of it. And I know that Azure Machine Learning is not the only tool that does this. There are a few out there. There's a lot of links, especially in that Slack group. People have put in a bunch of stuff that I've hunted down and found that do this kind of similar drift evaluation. But yeah, this being kind of built in is a nice idea, and something that doesn't really belong in traditional, so much in traditional software development, because everything's done by the human, not by the training. Yeah.
Is there a notion of drift for traditional software? Like, does the software app change? Like, I mean, for me, for machine learning, it makes sense because the behavior of the model is learned from the data, right? That's where it gets its behavior from. Versus traditional software, I guess the behavior of it is a little bit more deterministic. It's like, like it happens in that build step maybe, or it's like compiled beforehand. I don't know. Is there a comparable sort of thing, to drift in traditional software?
Yeah, it depends how you think of it. Like, you could consider that user behavior is the data. So if people are not doing as much purchasing on your site as they were before because the external environment has changed, then that could be considered drift. So let's imagine, I don't know, let's think about a club, or not a club, a restaurant or something like that, that had an online booking thing, and then suddenly COVID hit and everybody's locked down. That what's happening in production is a drift from what used to happen in production. And so that necessitates some kind of intervention by developers. It's a bit more manual, I guess. Your monitoring can definitely pick that up to say people aren't doing this thing that they used to do. Let's investigate what's going on. But the solution to that, I don't think you can really automate. You can't just say, oh, let's automatically build a new feature to account for that. Whereas with drift, you sometimes can. You can say, well, we've got this new data. Let's just retrain over that data. Does it perform better? Great. Let's use that model instead. It can be completely hands-off. But yeah, I don't think there's a direct parallel. I think that's probably about as close as I can get.
I think that's a great one, actually. All software has data, right? It has some data, but maybe not as much data. Or I guess one difference is that the behavior of the actual application itself is not maybe learned from the data, which is, I guess, what machine learning is, right? You don't have to actually program everything. It learns on its own, right? But it's not, again, there's some human in the loop there, but yeah.
Yeah. And you can have, and again, I'm not the ML expert, but you can have stuff that's learning as it's running, right? So when it's in production, it's improving online itself learning continuously. Yeah.
Yeah. Online some application. Yeah. Online learning. Yeah. There's definitely some needs for that.
And so that's almost doing this loop a little bit itself with the application that's running in production, right? It's kind of going through this retraining loop to some extent itself as part of its operation, I guess. Yeah.
This is great.
Yeah.
I love the little the animations here. That was great.
Do you know how long that took me? It's amazing.
Yeah, that would have taken me forever. I was
going to say the same exact thing. I was like, oh, that was really fancy. So if anybody's listening, go check out the video because it's worth the animation part at the end here.
Yeah, I've used these few slides a few times. I'm just going to admit that.
That's cool. All good.
Didn't waste it.
Yeah, don't reinvent the wheel.
Yeah, so this has been brilliant, man. I really appreciate you coming and talking to us about all this.
Yeah, of course.
I mean, for me, it is something that is very top of mind for a lot of people. MLOps is this new term that has come out, and you have the traditional software developers saying, but that's just DevOps. Or you have people who are not so sure about it saying, what is this? Is it completely different? Does it have some overlap? And it feels like you can do a little, cherry picking from DevOps, and you get the best, and then you can create, it is its own separate thing, MLOps, because you take the best of the DevOps world, but there are some applications that you need to keep in mind with ML.
Yeah, for sure. And when I first got into it, it took me a while to feel comfortable talking about it because I didn't want to be that guy who'd be like, just use CI. What are you talking about? When I didn't know the domain, So,
perfect. Well, I really appreciate you coming, and I'm going to just, talk a little bit towards the elephant in the room, which is Damien's in Australia. David is in New York. It is early and late, or late and early, depending on the way you look at it. But for me, it is absolutely the middle of the day. So you can tell who was selfish about this one.
This is great for you. Yep.
Yeah, everybody knows who scheduled this meeting right now, don't they? Because it would have been a lot easier, I think, if both of you were during the day and I was late at night. But
all good. I had fun though.
So thanks, guys.
International world at the moment. We're all used to it, I think. Yeah.
Totally.
Yeah. Well, thanks. Just want to say, this was a great conversation, Damien. I really appreciate the feedback that you give on the Slack channel. Guys, he seems like a really cool guy. So anyone listening, reach out to him. I'm sure he has some great wisdom to impart. But guys, we want to thank you for taking the time to listen to this episode. Please be on the lookout for some of the other initiatives that are coming up. We have the engineering lab, some other cool things. And I hope you guys have a great rest of the day.
All right, guys.
See ya.
See you later.